Okay, so I guess we are good with epsilon greedy. Now let's add UCB approach, which is upper confidence bound. So this would be slightly different because it has some more complexity involved, but not too difficult. So we will understand this also. Define explore upper. Okay. The parameters will remain same, only the execution will be slightly different. So iterations equal to 1000, no epsilon required, and this will also return us the list of int comma int. Okay, so the first thing here is to arm selection. So unlike the above two where we completely outsource the arm selection into random way, this has a specific way to select the arm, which is based on the formula that we have, previous estimate plus 2 LNT, which is total visits by number of visits for this arm. Okay, so arm selection, then estimation update, and then iterations. Okay, so these are the three steps. We will see what does this mean. First, let's start with arm selection. So unlike other methods, here we follow a different approach. So select underscore arm, which will take two parameters, visits, which would be list of integers as we have seen earlier, and the estimates, which will again be list of integers. Okay, and then the return type of this is expected to be an integer. So what we will do is we will iterate through each arm. So for I in range, env dot total arms. Okay. If visits of I equal to 0, if that means this arm has been never visited, so we will just return this arm right away, because in this also we want to follow the same methodology, which is if an arm is not visited, return it directly. Okay. And we will have some UCB values otherwise. So this would be 0 star env dot total arms. So now we are sure that since this arm has already been visited, so we will compute the bonus factor, which is square root of, let's put numerator first, 2 star log of total visits. So total visits also, I guess we should pass in here. Note that we are passing these values, but we are not updating it. We have an estimation update function which will take care of that. Okay, so total visits, square root of this one, and then this is our numerator divided by, so in our formula ni is the number of estimates, so we will have visits of I. Okay, so this will be the bonus factor. Okay, now we will do UCB underscore values. We will update that particular UCB value equal to UCB value, or actually we can just do plus equal to bonus. Okay, so this will basically increase that UCB value. So once this is done, we iterate this through entire for loop, and whatever we get, then we just return argmax of UCB values, meaning again the same thing that we discussed. It will return the index corresponding to the maximum value, which is basically the arm ID. Okay, so this is how we select the arm. Now for each selection, we also need to update the estimates. Okay, so update estimates. So we will have arm underscore ID, which will be of type int. Then we will have visits, which will be of list of int. Then we will have estimates, which will be list of int. Then we will have total visits, which will be of int. Okay, and this will return us a tuple of these things which are being updated. So visits, sorry, it should be list of int, comma list of int for estimates, and total visits also, which will be int. Okay, so let's implement this. So we need to first, for the given arm ID, visits of arm ID plus equal to 1. Okay, that is one thing. Reward, oh wait, I think we also need to have reward, so let me put it here. Reward, which will be integer. So reward minus existing estimate divided by visits of arm id. Okay, so this will be the new estimate, and then estimates of arm id equals to new estimate. Okay, so this is how the estimate thing works. And let me have some space, and then we will return the updated things. So we updated visits, we updated estimates, and we updated total visits. I guess that's all. Existing estimate is a temporary variable. Yeah, now we will use this to update it and keep on selecting the arms. Okay, so again, for underscore in range iterations. Okay, now what we'll do is so we will first just select an arm. So arm underscore id equal to select underscore arm with and I think we need to initialize visits equal to 0 times environment dot total arms, estimates equals to 0 times environment dot total arms, and total underscore visits equal to 0. Okay, so select arm visits comma estimates comma total visits. Okay, so this will be my arm id. Once we get the arm id, then we will get basically we will update the estimates. So we will do what? Visits comma estimates comma arm underscore id equals to, and actually we will need the current reward also, no, because then we will have that. So let's have one more return type, which will basically be int, and after total visits we will just return reward also. So let me copy this whole line, equals to oh, I think we don't need reward because we are anyways passing it here. Okay, my bad. So we can just do reward equal to env dot compute reward arm id, update estimates, which needs arm id comma reward comma visits comma estimates comma total visits. That's all right. Okay, so we get this one and we keep on updating this, and what we will do is yeah, we will have a result which is an empty, the same thing, result dot append. We will have arm id as index and corresponding reward. Okay, so I guess this would be the final for loop, and then we'll return the result. I know this is a little complicated compared to the other two methods, but I hope you got the idea. So basically we select an arm, we have our own estimation function. This are the selection mechanism. This is the bonus factor, which is basically this part, if you see this whole thing, and then we are adding it to UCB values, getting a maximum UCB values, basically the arm corresponding to the maximum UCB value, and then we are doing all this iteration. So that's the idea behind the UCB, and let's run it out. And result, I guess we need to do one change here. We are not supposed to do it here. I'll tell you why. See, we are getting the updated estimates, and estimates is what keeps our rewards. So what we can do is for index comma estimate in enumerate reward. Okay, not reward, estimates, because estimates is where all our computation is going. So putting result here won't make much of a sense, because this is a temporary reward, right? After all the rewards we get the final estimate and all. So we will do result dot append index and estimate. Okay, so this is actual code. Now this will make a lot of sense, because Now we already computed all the updated estimates, and then we are using it to finally return to the award. Okay, so this is our UCB. Let me run this up. I hope this goes. And oh, earlier we had explore, so let me do one thing. Random result. Okay, or maybe, yeah, and then greedy result. Let's, for now, because it's normal greedy, so nothing. Epsilon greedy result, explore greedy 0.1 should be good, and then finally UCB result.
It's 9 hours.
Iterations equal to 10,000 for each of these. Iterations equal to iterations. This will be better because then we will make sure that all of this is consistent. Okay, so these are the 4 algorithms. For now I would just comment it out and we'll run and see if we run into some errors. Once this is done, then we will start to plot it all.